Okay, so here's the entire content of this section on linear functions in your book. I just need to tell you what the word linear means. Okay, so a linear function, right, and I'm defining the word linear, is a function from R to R, and really this can be expanded a little bit, but for right now we'll go with this, with constant rate of change. Cool? When I'm saying rate, good. When I'm saying rate of change, what are you thinking?
Slope.
You're thinking slope. Okay, so if a function has a constant slope, right, what is it?
A line.
Yeah, it's a linear function, which is also a line. Okay, so that's the other statement. One statement, a linear function has a constant rate of change. Second statement, this is maybe some little theorem or something. The graph of a linear function is a line. Here, check. Good? Cool? This is what I want you to know about linear functions. That's it. Their graphs are flat.
Can it
Right?
be anything else?
No.
No? Never?
No.
It has to be an real number world too? Can it be anything else?
Yeah, so the reason I'm saying from R to R is that there are things with constant rate of change on different domains. They're not all of a line. Right? Like if I say, okay, here's an example. This is a function where the rate of change, right? The rate of change is always 1. Maybe let me put some points on here to convince you that it's 1.
Oh, now.
Okay. At any rate, it had constant rate of change before, right? Regardless of the labeling of the axes. But that thing's not all of a line. You see that?
Yeah.
Yeah, it's kind of missing like this stuff. And so for me to say this statement about the graph of a linear function is always a line, I really have to say this thing about from R to R. If I let this bit relax, I'd have to say something over here like a line or bits and chunks and parts of a line. And that would maybe be less convenient. You guys cool? You could also phrase it that way. That would be totally fine.
If you were to take like a segment out of it, would it be a linear function?
Yeah, so if I were to do something like this.
Yeah.
Yeah, that's really the same thing. I'm not going to call that a linear function. I'm going to call that a linear function with a restricted domain. You guys see that? I want linear function in your head to go with all of the line. What's up?
It's gonna, it's like if you would kind of rewrite it in that case to be an infinite domain, an endless domain instead of R to R. Would that be synonymous?
No, they're bigger things. Yeah, so there are further places that this could start at that are bigger, in which case I'm still okay with using the word linear here, but I don't want to talk about what they are today. Cool? So one example that you guys have all seen because you've had trig class is we could do C to C, right? From the complex numbers to the complex numbers. But figuring out what a rate of change is there might take us a little longer. Right? We'd still do the difference between the outputs divided by the difference between the inputs. But dividing in the complex numbers is a little bit subtle and we maybe should be a touch careful. This is all still true there, but it is a little bit more complicated. Cool? Questions, thanks?